Hi guys, my name's Nicole Goodman, and what I decided to do for my final presentation was have me speak and show you my presentation along with watching the PowerPoint, so you were able to see a video that I actually created that's inside. I wanted you to be able to see exactly one of the theories that Galileo had was done on the moon, so I thought it would be pretty cool to incorporate this in my final presentation. Before Galileo, there was Aristotle. Aristotle believed that objects that weigh heavier will fall faster than lighter objects. This theory was believed for over 2,000 years. And as you can see, I have a picture of the Leaning Tower of Pisa, and I have two balls, one falling actually faster than another, which in his theory, that would be the heavier one, and that would be the lighter one. Galileo Galilei was an Italian mathematician, philosopher, and astronomer. He was known for creations like the telescope and, of course, the theory of law of falling bodies. Aristotle's theory was challenged by Galileo. He took two balls weighing two different weights and dropped them at the very top of the Leaning Tower of Pisa, which is why I have Aristotle's version, and then I have Galileo's version, which shows two balls falling at the exact same time rather than Aristotle's version. What he found was that in the absence of air resistance, all objects will fall in the same uniform acceleration.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Mr. Galileo was correct in his findings.
This was actually done in 1971. It was David Scott went on the Apollo mission, and this is what they chose to do. So I thought it was pretty cool when I found it that they had actually tested a theory of the Italian mathematician I chose to do, and they actually tested it on the moon, which I think is pretty cool. He also had a theory between time and distance. He wanted to see how fast an object would fall. So Galileo built a ramp that would slow down the speed of a moving object so he could measure its speed. His findings were that the distance that an object travels is equal to its time multiplied by 2. Right here I have a ramp. As you can see that if something goes 1 second, or what I did was I took a Mississippi, so we would count Mississippis. If it went 1 Mississippi, it would go 1 unit of distance. If an object went for 2 Mississippis, the object would go 4 units of distance. That every second or Mississippi that an object would travel, it would double in its units of distance of time. And then an actual ramp was built like this, made out of wood, that Galileo actually built when he did this. Galileo was actually the beginning. He went down in history for many theories and experiments. Another experiment was one with marbles to understand the concept of inertia. After his death, many mathematicians used his theory, one being Isaac Newton. Newton was best well known for creating his laws of motion, which all of us learned in elementary school. Where he got Galileo's examples from and used a little bit of his marble experiment was his law of inertia. An object at rest will continue to stay at rest unless acted upon by an outside force. An object that is in motion continues in motion with the same speed and in the same direction unless acted upon by an outside force. What I learned when I did this report is that weight doesn't always matter in any type of instance, like in Galileo's and Aristotle's. It's easy to believe Aristotle's made sense because anybody would believe that something that's heavier would actually probably fall first. I also learned that the distance between time and distance actually has a relationship, that it doesn't matter how fast it goes, but the distance will always be multiplied by 2, which I found really interesting because sometimes maybe you would think it would always be faster, but it shows that math has always had some type of relationship inside to show you how it actually travels. So you're actually always able to figure out maybe how long it takes to get somewhere, or how fast something could fall, and potentially use it for obviously greater use. And what I also learned that I think was most important is that where would we actually be without Galileo? Even though people caught on to him, I believe that he started something and he created something that allowed other people to only make better. And somebody might have come along and done the same things that Galileo did, but he was actually the first. So the one thing I learned the most is that he has one of the biggest hands to me in any type of math theories or experiments. And I know that when I grew up, I learned about Isaac Newton, but I never fully knew about Galileo, which shows that if it wasn't for him, who knows what Isaac Newton could have created. So I believe that he was actually one of the original creators, which I found to be most interesting. So, but this is the end of my presentation. I hope you liked it. I think that it's really cool that, like I said before, that they did something on the moon with them. So that's it. Thank you guys.